Hi, in this SPSS lesson I want to show you how to conduct the chi-squared test for independence on two categorical variables. So here we have a data set called t-test independent example1.save. It consists of three variables. The first variable is nominal level. It's represented as with string values in SPSS. So a value of EXP means that the student here is in an experimental group, and we're using an experimental curriculum to teach some topic. CON means you're in the control group, and those students received a control or traditional curriculum to teach that same topic. The second column shows a numeric variable score, which is test score at the end of the course. But we're not going to ignore that today. We're going to look at column 3, which is an indicator variable called pass. So pass is equal to 1 if you're above a certain cutoff score, in this case 20 points. And it's equal to 0 if you're below that cutoff score of 20. Alright, so we're going to conduct a chi-squared test of independence to see if there's an association between the categorical variable group and the categorical variable pass. So let's proceed to do that. So we're going to go down to Analyze, Descriptive Statistics, Crosstabs. Once we get there, we see that the variable group has already been entered. But let's say that we're doing this for the first time. We'll see all the three variables here. And again, we choose one of these categorical variables and call it the row variable. We choose the other categorical variable and call it the column variable. It doesn't really matter which is which. Now let's go over here to statistics. And let's, yes, we're going to request the chi-squared statistic. And we could, if we want, also request the phi coefficient to be calculated. The phi coefficient is like a correlation between these two variables. But you can use it on non-numeric variables as long as it's just a 2x2 table. But we won't do that. We're just interested in the chi-squared test today. So that's all we need to click. Then we go continue. And now we're just going to go OK. And what happens? Well, let's see. It says it processed 22 cases total. And it assigned those 22 cases into the cells of this little 2x2 matrix. So the rows are the values of the grouping variable, control, or experimental. The columns are the values of the pass, the test indicator variable, 0 or 1. And you can see that we have quite a different distribution in the control group and the experimental group. In the control group, only 3 out of 10 pass. Whereas in the experimental group, 9 out of 12 pass. So you can see it's quite a different pattern, and we'll expect that. That really means that our eyeballs tell us that there is an association. That is, whether you pass or not seems to depend very strongly on which group you were in, control or experimental. When we get to the chi-squared test, we'll see inferential tests to support that conclusion. So here's the value of the Pearson chi-squared. Chi-squared observed is equal to 4.455. The degrees of freedom for that test is 1 for a 2x2 table. And the p-value, two-tailed, because chi-squared is naturally two-tailed, or corresponds to sort of a two-tailed hypothesis. We don't really care which direction the association is in, whether experimental subjects are more or less likely to pass the test, doesn't matter. So the sort of two-tailed p-value, in a sense, is 0.035. That's less than 0.05, our chosen alpha level, so we conclude that the test is significant, and that means that there's a significant association between the group you're in and whether you pass the test. That is, the two variables are not independent.